Greetings and Happy New Year from Toronto, Ontario, Canada. This is Andrew McDonald from the PacNext team, and I'm very much looking forward to being your moderator today. We'll wait just a couple of minutes while everybody joins in. Seeing lots of people joining. Great to have you. Happy Wednesday. We'll wait just about another minute to the top of the hour to let some more folks join in. Well, once again, Wednesday greetings from Toronto, Ontario, here on the shores of beautiful Lake Ontario. Great to have you with us, tuning in from Canada and all over the world. My name is Andrew McDonald. I work with the PacNext team on various sustainability and circular economy initiatives, and I also do some teaching at Ryerson University here in Toronto in the School of Graphic Communications Management. On behalf of the PacNext team, I extend best wishes to you and your colleagues and families as we continue to navigate this tough second wave of COVID-19. In the midst of all that's going on, we hope our webinars can brighten your day by offering some interesting knowledge and insight. So before I introduce our three knowledgeable, fantastic presenters, a few quick items. So first up, PacNext, at its heart, envisions a world without packaging waste. And the PacNext team offers you deep knowledge and experience of the complete packaging life cycle. So Dan Lance, Alan Blake, and I aim to be your go-to for high quality resources related to packaging, sustainability, and circularity. And so just one example is our packaging circularity course, which you see briefly described on the slide in front of you. It's led by Dan Lance, and our next session will be, as you see, toward the end of March 22nd and 23rd. So you can jump on pac.ca for more details and to sign up. In addition, please mark your calendars for February 234 for PAC's 1 of 100 Summit with keynote Michael Lee Chin and the live announcement of the PAC Global Leadership Awards. It'll be a great few days together. A few housekeeping notes. So our webinars typically end at 5 minutes to the hour. So today, 5 to 1. At that time, we'll post a poll. So we greatly appreciate your rating of today's webinar. And as far as the Q&A, we'll have about, we hope, 10 to 15 minutes. That's typically what we have for Q&A. And you should see the Q&A option either top or bottom of your screen. We welcome your questions. Please, any and all questions, send them. And I'll do my very best to field them during the session. We aim to address any outstanding questions in our webinar follow-up, along with a set of key takeaways and a recording of the session. So without further ado, let's begin today's session, a journey to plastic circularity. And our first guest is Charles David Mathieu-Poulin. Charles David is TC Transcontinental's Senior Advisor, Circular Economy, where he oversees TC's efforts toward creating a more circular economy for plastics. TC was the first Canadian-based manufacturer to join the Ellen MacArthur Foundation's New Plastics Economy Global Commitment, and recently announced the creation of a recycling group within its packaging sector. Charles David has been working in sustainability at TC since 2012 and was named one of the top 30 under 30 sustainability leaders in Canada by Corporate Knights in 2016. So welcome, Charles David. Great to have you with us, and over to you.
Thank you, Andrew, and hi, everyone. I'm really glad to be here. So yeah, just talking a bit more about TC's plastic circularity. Let me just switch the screen. There we go. Yeah, so just myself. So Charles David, also known as CD on the English side. As Andrew said, I've been working at TC for 8 years. A lot of you probably know TC Transcontinental as Canada's largest printer, which we have been for multiple years. We are also now a leader in flexible packaging, mostly in North America and Latin America. 2.6 billions of revenues, more than 8,000 employees, and about 40 operating facilities all across the US, Canada mostly, and Latin America. What do we do in packaging? Well, it's mostly, again, flexible packaging. We're talking about pouches, about shrink wrap, mostly for dairy, coffee, pet food, agriculture, especially in LATAM for banana bags, and a lot of consumer products. So we pretty much do the whole process of flexible packaging from the design. We have some pre-media offices, notably in Toronto. We have a big one where we do the pre-press and the design. We also extrude film. Again, we have a big extrusion facility in Whitby, Ontario, but also some in Griffin, Georgia, and Ontario, California. We do metallizing. We, of course, do printing, which is, our biggest ability. We do lamination, conversion, and then we added the last one, and that's what we're going to talk about today, which is recycling now, which is our new baby in 2020. So to talk a bit more about our plastic circularity journey, as I mentioned, TC has been in transformation from being solely a paper printer to now a manufacturing company that is pretty much 50-50 on paper and plastic. We did the big acquisition of Coveris Flexibles Americas in 2018, which was really kind of the big move for us that made us a flexible packaging leader in North America. And that brought, of course, new challenges with respect to sustainability, knowing that we were now dealing with plastic, which is a different material than what we were used to, which is paper. So one of the first big moves we did is that in March 2019, we became the first Canadian-based manufacturer to become a signatory of the Ellen MacArthur New Plastics Economy Global Commitment that a lot of you probably know about. And through that commitment that we took, well, we decided to create a three-prong approach to plastic circularity. So the first part of it is that we want to innovate and do a lot of R&D so that 100% of our packaging that we do will be either recyclable, compostable, or reusable by 2025. So that one is really focused more on new products. We also want to promote the use of post-consumer recycled content. And we took the engagement that we would get to 10% use of PCR by weight across all of our packaging by 2025. We'll deep dive a bit more on that one in the next few slides. And then, well, for all of this to happen, we know that collaboration is key. So we also took the commitment to get engaged with industry partners to increase the reuse, recycling, composting rates for plastics in the communities where we operate, mostly here in Canada and in the US. So as I mentioned, the next step in our journey was really in 2019, where we started launching some new products, which were part of that innovation. Some of you that are in Quebec and Canada probably know the Publisac well. The Publisac is really a plastic bag that is used in Quebec to distribute door to door every week all of the printed flyers. So this is where both of our businesses kind of get together. So now that we were a flexible packaging manufacturer, we decided to take control of making the bags of Publisac ourselves. And we felt that it was a perfect vehicle to bring a lot of recycled plastics in. knowing that, obviously it's not a food grade application. So in September 2019, we came up with our new Publisac, which is made from 100% recycled plastic. It's now distributed every week to more than 3 million doors in Quebec. So you can understand it's a pretty big volume yearly of recycled plastics that we're putting on the market. We also launched Viverte, which is our sustainable product portfolio, which comprises all of our recyclable, compostable, and PCR products. Viverte, which literally translates to green life, is kind of a little nudge to our French speaking, because we're headquartered in Montreal. And then it comprises a lot of products that are I'll explain here in the next slide. First, on the compostable side, so we are really a leader in compostable packaging, notably for coffee and snacks. In 2018, the peanut bag that you see there won the FPA Gold Award for Sustainability. So this is a bag that you can find in a lot of different stadiums in the US, mostly football ones. So what people used to do is obviously they would have those peanuts, they would shell them and then throw the shells on the floor, and then it would be mixed with the packaging that was not compostable. So we designed that one in order for stadiums now that when they just wipe it off the floor, they can actually combine the shells and the packaging. We're also doing a lot with coffee, as I mentioned. On the recyclable front, so a lot of the packaging we do for food is multi-layers and multi-material, meaning that we have barriers, notably for cheese, for example. So what we came up with in the last few years is a new line of all PE, barrier and non-barrier platforms and products. So what we did is that we managed to keep some of the same capabilities of a multi-material pouch, but to put it only in PE polyethylene, meaning that it will be recyclable. Here in Canada, it could be in some areas in the municipal recycling, but in the US, it would mostly be in store drop-off. Again, we were very excited winning the 2019 Gold Award for Sustainability at the FPA with our Harney & Sons loose tea pouch that is all PE. So we're really excited to win that one 2 in a row. And then the last one of the family, as we mentioned, is the Viverte PCR. So it's products which contain post-consumer recycled plastics. As I mentioned, the Publisac. We also came up recently with Coca-Cola for the HaHa brand, with a new shrink wrap that has 30% PCR that came up on the market in the US just before the holidays. And then if you finish on the last few months of last year. So one thing that my colleague Marianne will talk about a little more later is that TC is one of the founding members of the Circular Plastics Task Force, which is a project that we started here in Canada and Quebec to help build a more circular economy. You'll hear more about it soon. And then the big news for us, which was in 2020, that we decided to create a new recycling group. So as I mentioned, we believe that PCR is really a thing for the future. And what we decided to do is do a vertical integration strategy and include recycling of flexible plastics in our own capabilities. So in 2020, we acquired the assets of EnviroPlast, which is a plastic recycler that is here in Montreal. And since then, in the context of COVID, we've been building the equipment there and starting to produce recycled resin that we're going to bring back into our production. This graphic kind of shows it well. As I mentioned, our current process goes from, top left, which is virgin resin, goes into the process of extrusion, printing, converting, goes to our customers, goes to consumers in retail stores, gets recovered, and that's where it would stop most of the time. So the idea for our recycling group is that we're going to get some of the sorting facilities waste, but also waste from other sources like post-commercial, post-industrial, and agricultural plastics, transform them into recycled resin that is going to become a new source of resin and replace some virgin resin. So we decided to include that in our own capabilities. the reason for that is that we felt it was the best way for us to overcome the challenges related to recycled content. Those challenges, and we discovered them while we tried to do the Publisac, is first of all availability. There's a lot of recycled content, well, not a lot. There's recycled content that is available for PET bottles, for example, or HDPE rigids. On the flexible side, the resins and for large volumes is really difficult to find, both in supply but also in quality. So we felt that we were the best, to do it ourselves. You're always better suited by yourselves, and that we would create more availability to reach that 10%. There's also a lot of issues related to regulatory compliance. A lot of our products are food grade applications, and therefore they need specific FDA approved resins, which don't actually exist right now in flexible packaging. So this is definitely going to be one of our big goals for the next year or so. Also quality. If we control, the resin, we know what type of quality we need in our products, and therefore we are able to control it better if we are the ones doing the resins, have a more consistent resin, and obviously by doing it ourselves, and we can control cost and remove the middleman for our supply. So this is kind of why we decided to do it. The next steps for our recycling group, as I mentioned, right now we have only one site, which is in Montreal. We're definitely going to do geographical expansions to get closer to our markets, to get closer to our other extrusion facilities in North America. We have some sortation technologies. I know Eric is going to talk about some of them later, but we have some sortation technologies that are coming in our facility in Montreal in the next few weeks, COVID permitting. We're going to have more wash and filtration lines that we're going to add definitely in our facilities. And what we're really excited about is try to work with our customers or future customers in some closed loop scenarios, which is, for example, if we have customers that produce waste plastics, either their own products that go to the market or even post-industrial, post-commercial plastics, to try to have those regrinded into PCR resins and then included in their own products, so that some of our customers really can say that, for example, their shrink is made of 30% waste that is actually coming from their own products. So that's our next step. So just to wrap it up, we understand that to create a circular economy, there's a lot of steps needed, and the whole supply chain needs to be involved. And that's definitely what we're doing and what we're hoping for. We also are there to support our customer sustainability objectives. We have, 70% pretty much of our R&D budget is going to sustainable products right now. We have a great team of R&D and that is located in the US, but all across North America. And we do have some turnkey packaging solutions that are already there. And that we strongly believe that our vertical integration of recycling will help accelerate the journey to include more recycled content. And I'm sure you'll get news from that in the next few months from our front. So that sums it up for me, Andrew.
Hey, thanks so much. Wonderful presentation, lots to chew on. And a quick note, if you join the presentation today, after the introductions, we will field questions following the final presentation, the third presentation. But please don't be shy. Send in your questions during the presentation, and then we'll take them up at approximately 20 minutes to the hour. So without further ado, we'll move to our second presenter of the day and welcome Marianne Champoux-Guimond. In her role as sustainability lead, Marianne manages Keurig Dr. Pepper Canada's sustainability initiatives and partnerships, from environmental stewardship to responsible sourcing and everything in between. Over the past couple of years, she has been deeply involved in KDP's circularity journey, helping to build partnerships with industry leaders, governments, and other stakeholders. Marianne is confident that KDP can play an active role in the development of a Canadian circular economy, namely through its role as a co-founder of the Circular Plastics Task Force. So without further ado, I'll turn it over to you, Marianne.
Thank you so much, Andrew, and thanks everyone for being here today and for having me and for this opportunity to share our circular economy journey. So I'd like to start by quickly introducing us as a company, since we remain fairly young in the public space. So Keurig Dr. Pepper Canada was born a little more than 2 years ago out of the merger between Keurig Canada and Canada Dry Nuts, which is the Canadian business unit of Dr. Pepper Snapple Group. So we're now the third largest player in the beverage industry in the country, with some 1,500 employees across Canada. We have a portfolio of beverages that includes many brands that you most probably know, starting with Dr. Pepper and with Keurig, of course, but including also Clamato, Schweppes, Canada Dry, Real Lemon, and many more. So these come in many different formats, which implies, of course, many packaging types and material. So our vision as a company is really to offer a beverage for every need everywhere as much as possible, but also to make a difference with every drink. So this is why when we merged, one of the first things that we did was to really try to come up with a unique combined sustainability platform, which we call the Drink Well, Do Good. So this platform is based on 4 key pillars of action. The first of which is environment. So we focus on how we can lower our environmental footprint and that of our products and packaging. The second is supply chain. So it's focused on responsible sourcing of our ingredients and other products. Health and well-being. So we work for greater transparency and offering healthier options to our consumers. And finally, communities to support local populations wherever we operate. So under each of these pillars, we have given ourselves strategic objectives and time-bound targets whenever it was applicable. These targets include sending zero waste to landfill across our North American operations, which is something that we've already achieved in Canada. Balancing all of the water that we use to produce our beverages, reducing our scope 1 and 2 greenhouse gas emissions by 30%, and our scope 3 emission by 15%, all of this by 2030. Responsibly source all of our coffee and brewers and much more. But let's focus now on our targets related to sustainable packaging and circular economy, since it is the main focus of our event today. So we've committed to integrating 30% PCR, post-consumer recycled material, across all of our packaging portfolio by 2025. And at the end of 2019, we had already reached 20%. So for plastic, more specifically, we have given ourselves the 25% target for PCR content. We also committed to 100% recyclable or compostable packaging by 2025. And at the end of 2019, we were already at 87%. So we will soon be releasing our 2020 CSR report and we'll be able to share more progress on these targets. So our first major endeavors in terms of recyclability was the transition in Canada of all K-Cup pods to the recyclable format, which we completed at the end of 2018. So I want to share a little more about our approach here, since it was really an important journey for us. So a couple of elements of the strategy that we privileged were key to our success. Starting with how we partnered from the very beginning with leaders from the packaging, the plastic, and the recycling industries, with PAC, among other leaders, to inform the design of our recyclable pods. So those partnerships and those leaders really helped us select the right material. So basically, we chose to move from a multi-layer number 7 plastic to a number 5 polypropylene plastic. So we wanted to do it the right thing, but we also wanted to make sure that we would do it right, and the support and insight that we got from these partners was very key. Second, following the design phase, we deployed extensive testing efforts using an innovative testing protocol based on the use of RFID technology to understand how our pods were behaving in recycling facilities. So the RFID technology basically helped us track our pods throughout the recycling systems in order to confirm their recyclability. So we wanted to make sure that the pods could effectively be sorted and recycled eventually in current infrastructures. And all of those tests that we conducted in 12 different MRFs across North America, among which 6 were in Canada. Those tests proved that, that our pods were able to be sorted and captured effectively. We then invested our time, efforts, and money, of course, in consumer education to ensure that our consumers knew now that our pods were recyclable, and most importantly, that they knew how to recycle the pods properly. So that was a huge undertaking. We conducted these efforts and campaigns across Canada on the ground, but also in stores everywhere. And these efforts are not over yet. So we know for sure that consumer behavior change does not happen overnight. We need to do this on a continuous basis. And this is what we are committed to continue doing in the future. Also, throughout this whole journey, we collaborated with all relevant stakeholders, again, be they MRFs, plastic processors, municipalities, federal and provincial governmental entities. We wanted to secure their support to make it possible for recyclable coffee pods to be included officially in Blue Box programs across the country. So that was very key in our journey as well. And we have made some great progress in that direction. And finally, we documented our journey along the way with different studies to measure our progress and support our outreach efforts. So all of this to say that, that we adopted a very rigorous approach, and through this approach, collaboration was really, really key along the way. It's also worth mentioning that we also developed our own commercial recycling program because we wanted our business clients to also have their own effective recycling solutions so they can recycle their used coffee pods in workplaces, hotels, hospitals, and so on. So this program that we call K-Cycled, we developed and deployed it with the help of our longtime partner, Mterra. It enables us to collect and take back the pods directly from our clients across the country. Those pods get sent to Mterra, who separates the pods and ensure the effective diversion of all of the pods components. So of course, the plastic gets recycled, but the grounds are composted and the lids and filter are sent to a waste to energy program. Even though we can do great things as a company, we know for sure that we're much stronger and we can achieve much greater impact if we partner with others. So it's been part of our strategy since the very beginning, and we have invested over $30 million since 2014 in collaborative frameworks in North America. Frameworks that are aimed at supporting and improving recycling capacities and technologies, and also supporting the development of a circular economy. So just last year, we were founding members and we supported the launch of the Every Bottle Back initiative, which is focused on PET recycling in the US, as well as the Polypropylene Coalition, also in the US, which is of course focused on polypropylene recycling. In Canada, as Charles David mentioned just earlier, we were one of the co-founders of the Circular Plastics Task Force, which is an initiative that we are immensely proud of. So that's a project that we created with our partners from TC Transcontinental, but also from Danone, Cascades, Dynapack, and the Chemistry Industry Association of Canada. The objective was to optimize plastics recycling in Quebec and Canada through a better alignment between end markets and the players of the plastics recycling value chain. So through this project, we want to identify and to trial concrete solutions to tackle the challenges of plastics recycling with the aim of making it possible for companies like us and like TC to increase our use of PCR plastics and also to source it locally on domestic markets. So our initiative, we think it's really unique and effective for many different reasons. starting with the fact that we really target the common good. So we didn't launch this initiative just to improve the recycling of our own products and packaging. We really initiated this project, and we target the common good and the objective of improving plastics recycling overall to the benefit of all players of the value chain. Second, we are action oriented, so we know for sure that the whole recycling systems needs to be revised, and many important and profound changes are currently underway. But we also think that it's possible to build and reinforce the systems and structures that are currently in place, leading to short-term impacts. And this is what we are trying to achieve through this project. Third, we follow a reverse engineering approach. So in the first place, we came together, the founders, because we all had the objective of using more PCR in our products and packaging, but we were also facing a similar challenge in terms of sourcing high quality material, finding the right volumes, the right grades, for instance, and finding it locally. So our project really looks at the challenges of plastics recycling from this perspective, starting with the specific needs of the market which we are a part of course, as companies, to see what can be fixed to achieve the needs of the market players. We are a credible, recognized voice. So we reached out to leading stakeholders with our project and vision, and it really worked. So we were able to attract fantastic partners, starting with ECCC, who became the main financing partner of the initiative, and also many advisory partners such as Eco-Entreprise Québec, Recyc Québec, the Retail Council of Canada, and many others. So we can count on them, on their expertise, and this really makes us stronger. We can also count on the precious support of our associate partners, who are retailers, MRFs, plastic processors, and other interested players who all share our vision, our objectives, and they want to support the project and to contribute to it with their specific expertise. So it really, again, makes us stronger. So where we are currently approaching the end of the first phase of the project. And during this first phase, we completed a thorough mapping of the plastic recycling value chain. And we started testing some preliminary solutions. The report from this first phase will be made available in the coming months. So stay tuned for that. And then we will be embarking in the second phase of the project, during which we will pilot really at scale in MRFs and at plastic processors facilities, those promising solutions that we have identified. So please do get in touch with us if you want to know more about the project, if you want to support it in any way. So you have the website address here, as well as our email address if you want to reach out to us. And finally, but also important, as a company, we're also looking at how we can bring greater circularity into our own manufacturing processes, and how we can also support the demand for recycled plastic. So one very concrete example of a step that we took in that direction was the recent launch in the fall of 2020 of our first coffee makers made in part with recycled plastic. That was a great circular economy project initiative that we developed with a Montreal-based plastic processor, Laverne. So Laverne basically provides us with a very high quality recycled resin that's produced just a few steps away from our own plant in North Montreal. And then we integrate this recycled resin in the manufacturing of our brewers. So with the Camirand and Camirand Plus, which are the two models that we launched this fall, we have achieved so far a 25 and 30% PCR average. And our objective is to launch several other brewers models with even higher PCR percentages in the coming months. So stay tuned for that. And we even want to go farther and beyond that by exploring, again, with the help of Laverne, how we can reclaim the plastic from our end of life and our return to store brewers to be able to introduce it into our new brewers in a very closed loop way. So once again, it's a step-by-step process that we follow, but always following a very rigorous approach. But we are really on a journey towards a greater circularity. So I would like to just end this presentation by showing you a very short video that really tells it all about this great project. So that's it for me. Thank you very much.
Thank you, Marianne. Lots of great information, and we will now move on to our third and final presenter of the day, Eric Camirand. Active in the renewable energy and waste management sectors for many years and an electrical engineer by training, Eric is CEO of Waste Robotics Incorporated, which he co-founded in 2016. Waste Robotics is a global leader in providing technology that designs and delivers state-of-the-art intelligent recycling robots for various sectors of the recycling industry, including but not limited to organics diversion, construction and demolition, fiber and plastics. Mr. Eric leads a passionate team of engineers in the development and delivery of intelligent recycling robots. So without further ado, over to you, Eric.
Hello, thank you. Can you hear me? Can you see my screen?
Yes to both.
All right. Eric Camirand, CEO and founder of Waste Robotics. Obviously, we're talking about the waste industry. We're working within the ecosystem of developing robots to sort through the waste industry. So any change that we're trying to affect in the waste industry, we need to understand this is a fairly consolidated industry. So the key partners of these three companies are very important into anything or any change we're trying to affect. So we are right now working with these people, trying to see how our robots can do better. There are a lot of places where we can intercept and sort plastics. So there's a lot of MRFs around North America, about 2,000 of them. So there's a lot of opportunity to deploy robots that we're showing here to be able to capture products and do things. For those of you who don't understand the business of sorting, we get paid to receive material, we pay to sort it, and in the end, we're trying to generate a product that is of quality high enough that it can be reused as PCR, for example, and limit the amount of material that goes to landfill. That's obviously, that's the end goal. Now, still a lot of recycling centers look like this. It's very unfortunate. Labor is more and more scarce. COVID just exacerbated that. The efficiency of these systems are low. The quality of the end products is also low because we were offloading most of this material, a lot of it, off to overseas, and that when that closed down, now the need for quality and efficiency just increased. And obviously, there's a lot of waste and material that just gets by these people and just ends up being landfill. So the idea of bringing robotics into this is that we're now capable of delivering more inexpensive sorting and has greater efficiency. Obviously, as I mentioned, we moved from a model where we were offloading this stuff to overseas. Now we need to keep it in here and manage it ourselves, so quality wins. If you can sort with quality, you'll sort plastic, your bales of plastic will be higher quality, you'll have a better chance of finding local recyclers to use them and redeploy them as PCR resins. And the nice thing about robotics or automation is the predictability and reliability of the system. So basically, you can actually know what you're going to do tomorrow. So the value proposition of robotics is pretty obvious. People are, the workforce is there every day. There's an improved quality and efficiency, but moreover, we're taking a really dull and dangerous job, and we're taking these people and moving them to more interesting positions. So robotics are really doing the dirty job, and we're going to use these people to better ends. So a little bit about our technology. We're more like a software company. The core of what we do is software. So we use off-the-shelf cameras, we use off-the-shelf robots, and we kind of write the software in between to recognize the material and send instructions to the robots to perform the moves. I'll show you a quick video that I will comment over now. So we make scanners. First thing we do, we have a scanner that looks at the material and in real time will identify material. And we will then, so for example, we'll see material that looks really alike like this, and with our hyperspectral signal, I'll talk more to that, we'll be able to differentiate them clearly and be able to sort them accurately. And then we dispatch these orders to different type of robots. So we have plastic recycling robots, we have construction and demolition debris robots. So we have different type of robots that with automation completely picks up material and sort. And they, because of robotics, they can work 24/7, never get tired, they show up for work every day, which is kind of new to this industry. So we designed this to be a possibility to refit into existing centers. And we have developed a lot of technologies that allows us to do really funky stuff like this destacking. It's a very difficult problem that we kind of solved, and that helps us deliver more efficiency. And I'll show you more to that right here. Now, if we go back to plastics and the sort of a circular economy and the ability to recycle, the sorting center is kind of the, in a circular economy is really key, because if you don't capture it, or if you capture it poorly or you sort it poorly, it becomes more difficult. One of the problems we see now is the packaging is changing quickly, and if we're using only AI system or humans, it becomes really difficult to sort. So when this container is changing from HDPE to PET or back to HDPE, like in these lids, we see it all the time. This becomes really difficult to create automated systems that can learn all the time. Like all these white containers, very hard to classify as either PET, PET, or HDPE. So we need to have systems that actually are able to see through this. And that's why we use, we don't rely solely on AIs. AI is kind of is a nice thing and helps us do a lot of things, but hyperspectral is really key here to be able to differentiate between these different type of plastics. In this video, we see, on the left, you see color camera. On the gray one is the 3D, and the other one is hyperspectral, and the final one on the right is AI. So that allows us to see clearly. So we use AI, we use hyperspectral, we use 3D. All of these we reconcile together to be able to collect a lot of data, and that makes for more informed, very informed sorting, better than anything's been done before. Now, every picture from every one of these cameras is saved to the cloud. We're the first technology to actually record everything that goes on into a line, on a line. So every pictures get uploaded to the cloud. We retrain, we can retrain the material. So if, for example, if bottle that we were not able to sort appears on the market, once we have 10, 20 examples of this bottle, we can scan it underneath, upload the pictures, retrain our model saying, oh, this is PET, you should classify it as PET. And the entire network of robots now has learned this. So we can train from one robot in Singapore, and all of a sudden in Montreal, if that bottles appear on the market, it can be classified properly. We don't need to retrain because the knowledge is sort of shared between the robots. So, and the other thing is kind of cool, and that's another product we're developing, is the ability to, this is a scanner, this is what it looks like. So we could deploy only scanners also. So we could collect a lot of data on waste. So if you want to be able to, in real time, we can see all this material go by. We can give statistics. We can do brand recognition because with AI, we can see brands. So there's a lot we can do now that we have eyes over the conveyor. And that becomes really interesting for traceability, for all sorts of things like EPR, like people want to know exactly why they're paying for EPR. Now that we have this data, it's all collected, we can actually go back. So in real time, we analyze this material. We send the orders to different type of robots. Like Waste Robotics has built itself on not using only one type of robot, but we don't care about which robot we're going to use and how many we're going to use. So we build a system that is flexible for that. And one of the other things that you hear about in the marketplace is, well, how many picks per minute your robot, and that's kind of a faulty metrics because that's not really important. It's important if a robot goes fast, but it's more important to have many robots working together. It's as if I tell you on a sorting line, I put only one guy. He's really fast, but I only put one guy. That wouldn't make any sense. You need a crew to be able to capture the material because you have more capture time and more capture rate. And we're in the business of capture rate and precision. So hyperspectral delivers precision and multiple robots delivers capture rate. We also, one of the other challenge in this sector is tools. Like the robotics tools were never developed to do trashy work like we're doing. So we had to develop different type of tools depending if it's heavy. We invented tools like this one with a spike. Is actually we spike the material and then we blow it off with air. We have we don't use suction cups. We don't draw on this suction cup that you see there. We push air through, which creates a venturi effect and actually is way lesser in maintenance. Now the end game here is to develop a sorting line that is completely autonomous. Like there's no humans on the line. Because if there's one U-bin on that line, it means this line will stop for lunch and will stop for breaks and will sleep at night. Well, if we can have a huge bunker in front of this line and nobody on the line, then the robots can work 24/7 and it can start capturing. We have all the tools right now. We have live bunkers, mechanical separation, optical sorters, robotics. We have everything on hand right now to be able to have these fully autonomous lines. And we also can make lines like this that are fully prepackaged. They can stand on their own legs. They can be outside and you can feed material through and you can sort. Now this robotics opens up a slew of opportunities for fairly small sorting centers. We don't need to aggregate tons and tons of stuff. The price is, the cheapest robots we make is about $200,000. And then depending on how many arms and all this, but it's equivalent to, it beats a person that you pay $12 an hour to do. So it's actually, it's a very enticing value proposition. I know I'm almost at the end of my time. We have several references worldwide. We have some in France, some in the United States. We're a highly experienced team. We've been at it for 4 years, and we have invested over $15 million in this technology, and now it's coming to fruition. So if you're interested in this, just contact me, and I can answer more of your questions. So thank you.
Thank you, Eric, Marianne, and CD for 3 excellent presentations. A lot of detail. And that's reflected in a number of excellent questions that have come in from our audience today. So I'll get right to that. And I've got questions for each of you. So I'll share them as equal as I can. And I'll begin with a question for Charles David. And that is this. So it's to do with sorting. And the question is, do the sorting facilities have the capability to sort plastics in a way that your facilities can take them in and make a high purity product? So for example, a high percentage of a single type of plastic like LDPE.
Yeah, thank you, Andrew. This is a great question. Obviously, this is kind of our goal in the next year, and it's also one of the goals of the Circular Plastic Task Force. So what TC did last year is that we visited, well, maybe not last year, in 2019, before COVID, we visited 8 sorting centers, mostly in Quebec and Northeast. And we also set up some waste audits of the bales of flexible packaging that these facilities were bringing out. And one thing we realized is that, well, first of all, right now, there's not a lot of value for the bales of bags and flexibles, just because nobody's really, buying them and making anything of value with them. And therefore, the sorting facilities don't really have any incentive to make the quality much better. We also saw that in between, the manual sorters and then the mechanical sorters, there was a large difference going from 30% of contaminants, at the worst, to maybe 10% at best. So the conclusion of that, and the conclusion also of the Circular Plastic Task Force, is that there probably will need to be a second over-sort of some sort after it comes out of the sorting center. So this is what TC has been doing. And therefore, our goal is that we will start buying sorting center bales sometimes this year or next year, and do an extra sort on them, and therefore be able to get only PE, which is what we're aiming for, and get that from 75% quality to 95, 98, which is what we can bring in our wash line and get some high quality as an output. So it's either we work with the sorting centers for them to reach that 95, 98%. At this point, we don't believe this is doable in the current context. So therefore, we will kind of do that extra step ourselves.
Yeah, wow. So great learning on your part in that, and from the task force as well. So I think that directly addresses the question. Thank you. Next question for Marianne. And this is to do with the example you gave of the PCR incorporated into the coffee brewers. And so the question is, what is the source of that PCR plastic? Is it from the waste electrical and electronic equipment, packaging, or other?
Yeah, that's a great question. Thank you, Andrew. Yes, the source, the main source of plastic that Laverne uses to produce our recycled resin is indeed waste electronics and electrical and appliances. These plastics are recovered thanks to recycling programs operated by Best Buy and Staples of this world. And the plastic that we use for our brewers is ABS. So that's the main source used by Laverne so far.
Okay, excellent. We go to Eric. Eric, how does a technology like Digimark, so digital watermarking technology, that is applied on the package itself, impact the robots? Does it help reduce the equipment needed? Is there any impact on that? With the use of that type of process?
It would only improve if we could corroborate with the watermark the product, then it would only help. So we could probably, with hyperspectral AI, we can define what is a product that we're looking at, and the watermark would just come and reconfirm everything. So it just helps.
Okay, and I'll just a quick follow-up from another audience member. Can you distinguish PLA from other polymers, other materials with your equipment?
Yes, it's clear. PLA has a clear signature, so we can clearly see what is PLA versus any other plastics.
Okay, very good. And I'll go back to CD, Charles David. Question for you. How do MRFs differentiate your recyclable plastic from the non-recyclable ones?
And a very interesting question. So what we realize, and again, through that step that I mentioned before of doing the waste audits and visiting, is that one of the contaminants, out of that 25% is multi-layer, multi-material flexible packaging, like the ones we produce, because the consumers assume or wish that it is recycling and just put it in the recycling stream. So what we realize is that the big step is not necessarily at the sorting center, because the sorting center actually for now cannot differentiate between a PE only and a multi-layer, and most of them just all end up in the same bale of flexible plastics. So for us, the idea is the more recyclable, flexible packaging we can put on the market, the more of them will actually replace the multi-material ones that we find at MRFs, even though we shouldn't. And there's a lot of consumer, of course, education to do. First of all, to put, on those recyclable ones, clear indications that these ones should be put in the recycling bins, and that people like us at TC want to get those to recycle them. And maybe on the other side, keep doing education that some of the other packages that have a ton of advantages for food safety and food conservation are currently not recyclable, and people should not put them in. So it's not necessarily an issue at the MRF level, because they don't really differentiate between the new ones and the old ones. It's really more for us to prevent having non-recyclable ones in the bales at the end.
Perfect, thank you, CD. Question for Marianne. Marianne, you spoke to KDP's involvement and contributions to the Circular Plastics Task Force. Question is, what is important for the task force success going forward? You described much of what has been done so far. As we look ahead, what is important to accomplish?
Well, we still have lots of work ahead, but it's going to be very important to launch the second phase of the project and to really embark on this journey. So for that to happen, we'll have to really carefully select the pilot projects that we will want to deploy, which will be those that will most likely have the greatest impact on plastics recycling. So that will be a very, very important step for us to select those projects, and also, again, choose the right partner to make these projects happen and facilitate the success of these initiatives. Of course, many things need to happen to ensure the success of this next phase, including how we will find the right financing partners, the right associate partners that will support the initiative. But the second phase will really be where we will see the concrete solution being put into practice, and that will be highly important.
Very good, thank you. And I'm looking at the clock, so we're a few minutes to the hour. I saw the poll go up, so if you haven't already, I can respond to that. We'd greatly appreciate it. And I think we've got time for one, or perhaps I can squeeze in two more questions, and then we'll close. So a question for Eric. Eric, you mentioned that you can determine the mass or the weight of different packaging formats flowing through the MRFs using your equipment. Can you just elaborate a little bit on how this is captured?
Yes, thank you. This is a good question. Because we use 3D sensors, we actually have a complete topography of the conveyor in real time, all the time. And because we can actually decipher every object one after the other, we can actually identify and even count objects. So we can, the mass would be a calculation based on agreed a typical density. But because we have very precise volumetric information, we can actually derive the mass. So that gives us a lot of information about what's going on the belt, mass, number of items. We could tag, as I said, we could tag brands. So we could have a complete lowdown on this. And the interesting thing, because we save all the data up to the cloud, we can sort of replay the tape if you want and perform other analysis therefore after. So for example, one of our clients right where we're picking out bags in Minneapolis, we ran an algorithm to discover that actually there was like 60 grand worth of aluminum cans that were just passing by, just by analyzing all the images of the last year. So these are the opportunities we now have by having these camera recording all this material.
Excellent. Okay, thank you. And I'll send the final question. And if Charles David, you could just keep your comment brief, but it's a good question. And that is, most of the recycling examples seen here are related to, or seem to be related to, mechanical recycling. Is Transcontinental investigating scaling up any type of chemical recycling to an economically viable state?
Again, a very good question. So we are obviously aware of and keep aware of everything that's going on in the chemical recycling sphere. You know, a lot of them are a few years away, probably, of being at a commercial scale where we can use what's coming out of there. It's definitely on our radar. Not necessarily anything short term. Not sure if it's going to be investments, or it's partnerships, or it's really just to try to use. And one point where we see chemical recycling to be good is for all of the waste plastics that we can't use with mechanical, to try to combine with chemical for those plastics to be used. So I think both of them will be in collaboration and in combination, and we'll see that in the next few years. But yes, on our radar for sure.
Well, thank you. And so we're unfortunately out of time for today. We have so many good questions. We tried to address as many as we could. We had a robust audience today. So on behalf of PAC and our webinar audience today, thank you to the presenters very much for taking your time to share your knowledge with us. We greatly appreciate it. And to our audience, thank you for joining us. We trust you've learned something new today. And shortly, we'll send out the recording along with our key takeaways and responses to any outstanding questions. So in the meantime, keep smiling, stay healthy, and we'll look forward to connecting with you again soon. Thank you. Bye for today.